All right, thank you for that nice introduction. My name is Ciro. I'm the CTO of Cobalt. I'm also the editor of the RIST specifications and the president of the RIST forum, which is a lot less work than it sounds. All right, let's go over the agenda. We'll start with what's RIST. We do a quick overview of RIST simple main and advanced profiles. And then we're going to roadmap what's here and what's coming. And then we'll have discussions and questions in case you have them, but feel free to interrupt me. This is a small group. If you have a question, shout it and we'll go for that. So what's RIST? RIST is an activity group. Reliable Internet Stream Transport is an activity group created by the Virtual Services Forum in 2017 to produce an interoperable broadcast-grade transport over the internet. Why? Because there were solutions like that in the market before, but they didn't interoperate. So it was actually, I think, ESPN that came to the RIST, to VSF and say, fix this thing here. We want an industry standard for that. And I'm not allowed to use the word standard. It's a specification, because VSF is not a standards body. There is the marketing stuff, because I'm also in marketing, right? Experts in the subject matter with hundreds of years of combined experience. So none of us is 100 years old, but a combined experience. The overall guiding principle is don't reinvent the wheel. That's the RIST AG chair says is the Lego approach. Take what works and only design the glue or whatever you need to make it to happen. The RIST forum is responsible for marketing it. So I have a little diagram here where you have the RIST AG guys, they do the standards, and then the marketing people, we promote the standards, and I'm actually in both. I'm the editor of the standard, I'm a president of the RIST forum. So I have to do a little marketing for RIST forum, so here's our members. We have leading members, these companies, that means they pay some money. Then we have associate members, which means they pay some less money. And then we have the affiliate members, which is a lot. There's more than 200 that they join for free. So if your company is interested in RIST, I encourage you to join the RIST forum. You just go to rist.tv and fill a form, and you can join. You can join for free if you want, and then you're going to be here. All right, major RIST milestones. That's a lot of stuff, right? We were created by the Video Services Forum. It was actually in February, but we didn't do anything until NAB. We had the breakfast meeting in NAB, and then we actually got it started. Took us a year to get something out, and then we did simple profile, the main profile, the advanced profile, and multicast authentication. I'm not going to read each one of these, but it's been an ongoing trip. RIST technical recommendations. So that's the RIST specs. They are published by the Video Services Forum as technical recommendations. We call it technical recommendations because we're not a standards body. The RIST AG prepares them, and they are approved by the VSF Board of Directors. And we have the main series of recommendations. They're all VSF TRO 6. So 6.1 is simple profile, 6.2 is main profile, and 6.3 is advanced profile. And then there's TRO 6.4, which are ancillary features. So we got the main stuff done, and then we said, well, what else can we do here? What is missing? And that's the TRO 6.4 series, a whole bunch of little things. Another important thing is RIST TRs are updated whenever it's needed. We treat it like software, right? There's a little new feature here, there's a change here, so they are updated. All right, main RIST technical recommendations. So we started with a simple profile. We published it in 2018 and revised it in 2020. We added some stuff to it after some discussion here at NAB. Main profile was published in 2020, was revised twice. There's a guy behind that that's making faces at me. That's one of the major contributors to RIST, ID Rosenberg. And then we have advanced profile that was published in 2021 and revised in 2022. We added some stuff there. Important thing, it's all available for free. Go and download it. Doesn't cost anything. So what's on each profile? Simple profile gets the data there. So you have ARQ and you have bond and seamless switching. That's the key, right? You get, that delivers the packet. Main profile gives you multiplexing, so you can put multiple RIST sessions in one tunnel and give you security. And security has both encryption to protect content in flight and authentication to make sure that you're connected where you think you are connected. And then we have advanced profile, which combines everything, and it's basically a reliable tunnel where you can do ARQ in the tunnel. So you can use RIST as a base for any protocol, transport anything you want over RIST. So I'm gonna give you some details, because if you go to the IP Showcase archives, there's full presentations now, all of these things. Simple profile, basic compatibility with non-RIST system using RTP. So RIST simple profile is an RTP stream. Anything that understands RTP just gets that. You may not get the packet recovery, but you get that. And to that, you add packet recovery using NAC, meaning if you don't get the packet, you request it and it comes back. And we even used an RFC 4585 that has the NAC message. So it was just like combine this with that and you have this. The features of this are bandwidth efficient. So you only send what you lost. And there's a knob. It's a tunable trade-off between reliability and latency. You have a good network, you can have low latency. You have a very bad network, it still works, but you're going to pay for it with latency. It's like the more time you have to do something, the better job you can do. That's what it is. Very important, IP multicast support. And he's going to do a talk on multicast later. Multi-link. Includes simple profile, includes multi-link support, which is, there's two things about multi-link. First one is seamless switching, where you send a stream, same stream on two or more links, normally two, but diverse links, and the receiver merges it. So if your link goes down, there's no glitch, right? So it's -7. And bonding is you combine multiple links for the higher bandwidth. So just like cell bonding. And we had demos of RIST using cell bonding as well. So that's the key things about simple profile. Packet recovery, multicast, and multilink. Main profile. Main profile gives you encryption, which is basically protect your content, and we have AS128 and 256, and authentication. And that's certificate-based authentication. It uses DTLS, which is the same thing, same kind of stuff. When you connect to your bank, and you want to make sure it's the bank, that's that. Same thing, same technology. We didn't invent anything new. And then tunneling, which is combining multiple streams into a single port. So you'll be more popular with IT because, oh, can I open just a port? And then you can put everything there. Yeah. All right. Security. Encryption is AS128 and 256. You can enable, disable encryption, individual encryption suites because AS256 is not legal in some countries. Here's okay, but there's some places it is not. And authentication is certificate-based authentication. And we have also PSK authentication. Why I'm talking about this? Because there is a multicast authentication thing is really cool. You have a multicast encrypted. The receiver authenticates against the server, gets the key, and then can receive it. And it's all very, very secure. So it's an alternative for CAS systems, and it's free. It's a fully documented. Go look at it in main profile, and there's an open source implementation as well. What about? Yeah. Yeah, but you can secure it with RIST main profile. So, and as I said, there's something called LibRIST, open source, that has that. It's there for free. So the multicast is encrypted. You authenticate securely. Someone can be looking, and securely you get the key. And then you can decrypt the multicast. If the guy, someone is decrypting the multicast and you don't want him to decrypt anymore, you can kick him out by changing the key, and he doesn't get the key, and he's gone. Or she, I don't know. Advanced profile is a way of doing RIST on anything. RIST is a basis for any transport. So it is a tunnel. There's no such thing, as far as I know, a tunnel with packet recovery, unless you use TCP, and there's other problems with that. But it's a tunnel with ARQ. And the main things are fragmentation reassembly and fragment level ARQ. So if you send a big datagram with IP, if not all the fragments get there, you drop everything. With advanced profile, you can recover that. And includes all the authentication and encryption that you had in main profile. And there's something called direct payload identification. So if you don't want to use it as a tunnel, you can just drop the whatever thing you want to send directly into the packet. Again, you can find in the archives of the IP Showcase full talks about all that stuff, and you can download it from the VSF website. And I know I talk very fast because I have a lot of slides. I want to also have time for discussion. So TR-006, 1, 2, and 3 are the basis that gets you there. And then TR-064 is the ancillary features. So the little things that we decide, well, we need that. Let's talk about that. The ancillary features are not necessarily part of any profile, and they are published as TR-064 parts. And so far, we have published 5 parts. They are available in the VSF site. So what have we published so far? What are the 5 parts? They are coming, and I'll talk a little bit about each one. We have source adaptation, which you vary dynamically the encoder rate or the distribution of the links based on traffic. People wanted the VPN. Main profile is a VPN, advanced profile is a VPN, but what about the standard VPN, Wireguard? So we specify that. RIST Relay. There's a full presentation IP showcase about the RIST Relay. It's making RIST work like Skype. So you like that IT thing? What about you don't have to talk to them at all to connect? That's the RIST Relay. Part 4, receiver synchronization. I've done a talk on that, and there's a paper on the SMPTE Imaging Journal with that technology. And then there's RIST Multicast Discovery. If you're interested in multicast, G, who's standing back there, he's going to have a talk on multicast. So I'm going to give you just the general view of each one of those parts. Source adaptation. One of the basic things you do is packet loss recovery, right? However, if the bandwidth ain't there, no amount of ARQ is going to fix that. You can't make a 5 megabit per second stream fit in a 4 megabit per second channel. That ain't going to happen, right? So you have to solve that as a source. Either you reduce the stream bit rate or you rebalance if you have multiple channels. And that is source adaptation. That's all I'm going to talk about. There's other presentations on that. Second part is use of Wireshark in RIST. RIST main profile is essentially a VPN. Some RIST users may want to use off-the-shelf VPN like Wireguard. So we decided to specify that. He doesn't like it. Ooh. Okay, my reviewer didn't catch it. Wireguard. See, I wrote Wireguard over here. It's Wireguard, guys, not Wireshark. There's but there's RIST plugins for Wireshark that you can get. So I saved it at the last minute. All right. So one cool thing you can do with Wireguard is, not Wireshark, is you can use the QR code. So you can do that, and that becomes that. And if you point your phone and say this, basically, you get that text over there, right? So if you have a RIST client that can look at the QR code, that's a way. It's just trying it. It's just the text. It's not going to give you access to anything. All right, the RIST relay. So you have a situation like that. A RIST client wants to connect to RIST server. The firewall at the client side is usually not a problem because it's an outgoing connection, right? Unless you have very, very crazy IT, it's not a problem. It's going out. Firewall at the server side will not let the connection in because that's what the firewall is for. So you have to call IT and get them to open it. Now, if you want to call IT, you want to make this easy, we have a solution for you, which is the RIST Relay. You have to put something accessible in the internet that will facilitate that. So features. Endpoints must log in because you are bypassing some level of security. So they have to be authenticated, authorized, and everything. Since they can connect from anybody, you need to have a directory. Just like Skype, you have the Skype handle, you talk to that person. You don't know firewalls is happening in the background, but you're connected to that. And one important thing is RIST Relay must support the concept of bypass, because sometimes, depending on the firewall, you can set state and then talk directly, so you don't have to relay. So support that. But you also must be able to forward the traffic, especially if you're doing one-to-many. It's like a CDN. And the endpoints must have some control. So let me talk about security. I have a full talk about this in some previous IP showcase if you went to Amsterdam. So we need to use an advanced profile, an authenticated secured connection, or it's not going to work. We don't allow anything other than that. And the authentication information identifies it. Endpoints are defined by human readable name. So you use a name. And this is published. I forgot to fix that one. And we use RIST Advanced Profile control messages for that, to set that. Decoder synchronization. It's a very important feature for the RIST. What is that? You have a whole bunch of encoders, whole bunch of decoders, and you want the frames that come into the encoders together to come out of the decoders together. It's very simple, and together means within a frame. So that's the requirements. That's the problem we try to solve. How do we solve that? We extended the mechanism used in RTSP for AV sync. If you're familiar with RTSP cameras, there's a mechanism for AV sync there that uses the sender report, and we extended that. We didn't invent anything new. So this is one of the applications, sports production, where you have cameras all over the place, and they have to have the same delay if someone is switching between them. Because if it's a soccer game and there's a goal, you have a camera here and a camera there, you may have missed it. They need to be synchronized. Does it work? Yeah, it does work. And I'm making a little commercial Cobalt there. We did a test over the internet. We sent 2 streams from the same source with time code, and then received it. I went from California to Illinois, received it, and the multi-viewer is just something that takes a picture of it. And here you go, same time code. And that's me talking about something else, talking about RIST, actually. Should have found a picture where my mouth's not open. Not very flattering. All right, RIST Multicast Discovery. And we're getting to the point, to the last thing that's done, then I'm going to talk about roadmap. This is actually pretty simple. We support IP multicast in the tunnels, and in some situations, you can save bandwidth by not sending a multicast where it's not wanted. So We just finished the TR-64 Part 5. It's a mechanism to provide this functionality. It boils down is use and process IGMP, use and process IGMP, or MLD, Multicast Listener Discovery, which is the IPv6 version of IGMP. One important thing is for complex mesh networks, a traditional multicast routing algorithm should be used instead. And Ajay, who's standing back there, he gave an IP showcase talk about exactly about this some years ago. All right, so I talked about the past and the present. Now let's talk about the future. What's next for RIST? RIST roadmap. What are we actually working on? RIST MPTS program selection. When you have an MPTS going out of a RIST, if you want just parts of that, don't send what I don't want, but it's an MPTS. So can I select all what I want? It's important. It'll be a TR. That's the next thing you're going to see out of that. We finished the technical work. I'm going to write that right after NAB, and it should be easy to publish. But with this group, they're always going to find something that is going to, oh, yeah, what about that? Okay. The other one is hybrid internet satellite delivery. When you use the satellite as your main channel, and if there's losses or rain fade or whatever, you use the internet to recover. I have a talk about that on Tuesday at the BITC, the conference. And risk control is a big problem, and we're looking at it. The RIST AG has the following in the roadmap. Congestion control, we don't know yet. There's some work on that. RIST and WebRTC, RIST and Quick. And we have done some preliminary work on these items, but they haven't gone to the full AG. There's nothing in front of the AG yet, but we're going to get there. So let me talk about the ones that are more or less done, which is MPTS program selection. I described it to you. Have maybe receiving a multi-program transport stream, maybe interested in just some programs on the MPTS. So it's a means to receiver, and you tell what you want, and the sender only sends you that. It saves bandwidth. It's an optional extension of RIST and main and advanced profile. So technical work is complete. We got an agreement between the AG members on what we're going to do. It just needs to be written. Hybrids internet satellite. There's this big deal about 5G and C-band. Okay. Ku-band is not a good option, and you can't deliver over the internet. So use the satellite for primary, use the internet to fix the select sites and legacy. So technical work. Risk control, we're not quite there yet. So we only decided what needs to be done. And we have retirements, and we decided on some, and I'm going very fast because Wes is looking at me. So this is still on the work, no decisions yet. And that was my last slide, Wes. How much am I? Okay, I talked really, really fast so you can ask me questions.